Welcome back to my YouTube channel, and in this video I'm going to be finding for the Fourier series of this value x over 2 from the period of 0 to 2 pi. That is, this period is equals to 2 pi. So now, if I find for the Fourier series, we know that we are trying to put it into this form, which is this, but what we need to get is our coefficients a naught, an, and our coefficients bn, which is what we need to get. So now let us move on with it. Our a naught is equals to 1 over pi, the integration from 0 to 2 pi, that is from 0 to 2 pi of f of x dx. So what is our f of x? X over 2. Therefore, this is equals to 1 over pi integration of 2 pi of 0. We have x over 2 dx. And if we integrate this, this is going to become 1 over pi into our here. After integrating it, we are going to get x squared over 2 multiplied by this 2 that is initially there before. That is x squared over 4 from 0 to 2 pi. So that is after integration. So therefore, this will be equals to 1 over pi times our x squared. This is going to give us 2 pi all square over 4 minus, when we put 0 over 4. And therefore, this is going to give us 1 over pi. Then we have 4 pi squared over 4. 4 cancel 4, 1 pi here will cancel a pi here. Therefore, the answer is equals to pi. So we have our a naught is equals to pi. Either way, let's just put it there. We have a naught is equals to pi. So what we need to get next is our an. Our an is equals to 1 over pi times the integration from 0 to 2 pi to 0 to 2 pi f of x cos nx dx. What is our f of x? This is going to be equals to 1 over pi times the integration of 0 to 2 pi. Our f of x is equal to x over 2. We have x over 2. What is our cos nx? Our cos nx is it's still cos nx, so we have cos nx dx. So now what does this resemble is that we are going to be using integration by parts. So first of all, let me bring out my coefficients here. So therefore, this is just going to remain x over here. I'm going to bring my 2 outside. We have 1 over 2 pi outside here. So now using integration by parts, we are going to be having u is equals to x, and dv is equals to cos nx dx. So therefore, if we differentiate this, du is equals to dx, and also if we integrate this, v is equals to 1 over n sine nx. Now the integration of cos nx is equals to sine nx, but using chain rule, we have 1 over n sine nx. So now that is for that. So now that we are putting the value for our integration by parts, we can continue by saying this is equal to 1 over 2 pi now into brackets uv, that is x times sine nx over the value of n from 0 to 2 pi minus v du, which is equals to, well, we can bring that 1 over n outside. We integrate it from 0 to 2 pi of v du, which is sine nx. Then we have our dx, which is pretty simple over here. So we just put our value. Now, one thing that we know is that at the value of 2 pi, sine nx will be equal to 0, and at the value of 0, sine nx will be equal to 0. So everything that is over here will be equal to 0 if you impute these values. So we can just move on further by saying 1 over 2 pi, and inside this bracket, this is already equal to 0 because if we have at x, at the value of 2 pi sine 2 pi over n, sine n 2 pi, 2n pi, yeah, and then we have minus 0 sine 0 over n. This will be equal to 0 and this will be equal to 0. So therefore we can just cancel it out. So we can just have this as we just move on to this place instead. We have our minus 1 over n, and now we are going to integrate this again. The integration of sine nx is equals to minus cos nx. So this will be equals to the integration of minus cos nx then over n due to chain rule that we are applying in the bracket here. So then our value of 0 to 2 pi, value of 0 to 2 pi. So we can bring out this 2n here, we can bring it out with the negative value. The negative value multiplied by this one would cancel each other. So therefore this will be equal to 1 over 2n squared pi. 1 over 2, the n that is n squared, and we have our pi. Then we have our cos nx here, cos nx from 2 pi, from 0 to 2 pi. So now from 0 to 2 pi, if we impute 2 pi into here, it's going to become 1 over 2n squared pi. Then we have, now if we impute 2 pi, we have cos 2n pi, cos 2, yeah, cos 2n pi, because x is equal to 2 pi, we have minus cos 0. So now, both values are very unique. If we have cos any value, let's say n pi or something like that, we have n pi, then this will be equals to minus 1 raised power whatever is at the back of pi, which is equals to n. So in this scenario, this will be equal to 1 over 2n pi, 1 over 2n squared pi. Then we have our bracket here will be equals to another minus 1 raised power 2n. Then we have cos 0, which is equals to cos 0 is equals to 1. So now, if we view this, we have minus 1 raised to power 2. Minus 1 raised to power 2 would be the main point here, because if even if n is an odd number like 3 or 4 or 3 or 5 or 7, if you multiply by 2, it will still give you an even number. So therefore, this is going to be even at the end of the day. That means 2 here is the main power. So therefore, this will be equals to 1 over 2n squared pi into brackets minus 1 and even number, raised by even number is 1 minus 1. And 1 minus 1 is equal to 0. 0 times everything will give us 0. Therefore, the value of an is equal to 0. The value of an will be equal to 0. So therefore, we move on to the value of bn here. We have bn is equal, bn here now is equal to 1 over pi times the integration from 0 to 2 pi of f of x sine nx dx. So now this is this, and our f of x here now is equals to x over 2. So that means it's equals to 1 over pi times the integration from 0 to 2 pi of x over 2 sine nx dx. So we can bring out our constant 2 out here. So it will just remain x, and therefore this will become 2 pi. So therefore we can be able to use our integration by parts, which we can use. Now u is equals to x, and therefore the v is equal to sine nx dx, that is this over here. So therefore our du is equal to dx, and our v is equal to, if we integrate this, we are going to get minus cos nx dx over n. So now that we have gotten our value, we can just impute them using integration by parts. Using integration by parts, we are going to get mm, so let me write my values out. You notice that we have gotten the value for a naught here is equal to pi, and we have an is equal to 0. So since I will know that now, so that I need to see space to continue with my solution. So now our value here are u, the v, the u, and the x. So now using our formula for integration by parts, we have our bn as 1 over pi, 1 over 2 pi, and now our integration here is uv minus v du. So we have minus x cos nx over, let's remove this dx here because it has been integrated already. So minus cos nx over n from 0 to 2 pi, and then we also have minus now the integration from 0 to 2 pi of v du, which is equals to minus cos nx over n. Then we have dx. So this minus here will cancel the minus here. So therefore, we are going to be having it as plus. And also this n which is under here can come out as 1 over n here. So now moving on, we want to imputing our value for, imputing our values for this place, for this side over here, we have it as 1 over 2 pi. Then inside my bracket here, we have minus, when x is equal to 2 pi, we have minus 2 pi cos 2 n pi over n here, minus, now minus another, the minus that was initially here, which is minus 0 cos 0 over n, which is for the second one. So since 0 has multiplied everything here, we do not need to write it again. Everything is going to be equal to 0. Now this is the only relevant one here. And also for our integration here, when we integrate cos nx, is going to give us sine nx over n. So therefore this will be equal to plus 1 over n, and the integration here will be equal to sine nx over n from 0 to 2 pi. Then that will be that. So now when we move on, it will be equal to 1 over 2 pi, 1 over 2 pi, minus 2 pi here will be minus 2 pi. Now we will have cos n 2 n pi. As I said earlier, everything here is going to be equals to, after we have 2 n over n here, we will have it as minus 1 raised to power 2n. And 2 is going to be the main factor here, but let's move on. We have plus 1 over n. We can bring this other n outside. So we have that 1 over n squared. We have sine nx from 2 pi to 0. So therefore we have sine 2 n pi, and we have minus sine 0. But sine, anything that is sine pi in all manners is also equal to 0. Sine pi, sine 2 pi, sine 3 pi, every single one is equal to 0. So that means we are going to be having 1 over 2 pi, and here we are going to be having, now here 2 will be the main power here. So therefore minus 1 is power 2 is equal to 1. So that is minus, which is 1. So therefore, this one is going to come outside. We have minus 2 pi over n, minus 2 pi over n, and then this is be equals to plus 1 over n squared times 0 minus 0. So this, since this is 0, it can just cancel out, and therefore we have it as this. Yeah, we have it as this, and here we have 2 cancel 2, and pi cancel pi, therefore this will be equals to minus 1 over n. That's our value of bn. So therefore our value of bn is equals to minus 1 over n. So now since I have our value, we want to write it in this form over here. We want to write it in this form over here. Therefore, we write it as f of x is equals to, what is our a naught? Our a naught is equals to pi. We have pi over 2. Then we have plus an is equals to 0. Therefore, 0 cancels out all the possibility of cos. Then our bn is minus 1 over 2. So therefore, we have minus, so this minus times plus will cancel. We have minus, then we have the summation from n equals to 1 here to, now from n equals to 1 here to infinity, from n equals to 1 to infinity of 1 over n, or in other words, you can just put it as sine nx nx over n. So now this is the Fourier series form of solving it. And sometimes they also do things like expand it, whereby we can have it as pi over 2. That we expand this formation here, we will have it as minus. We open our bracket, sine x over 1, we have plus sine 2x over 2 plus sine 3x over 3 dot dot dot, and we close the bracket, and this is what this means over here. It's equal to f of x, which you can also write as x over 2. So x over 2 is equal to this in form of sine and cos. So now this is how to find the Fourier series of any function. Thank you very much.